Good morning, everyone. In this video, we'll start with chapter 12, areas related to circles. First, perimeter of a circle. Perimeter of a circle is known as circumference. The constant ratio of the circumference of a circle with its diameter is denoted by pi. So circumference divided by diameter is pi. This is the definition of pi for us. Now, circumference is pi times diameter. We know that diameter is 2 times the radius. So, we can write diameter as 2r, where r is our radius. So, we get the formula for circumference of a circle as 2 pi r from the definition of pi. Now, area of a circle. In your previous class, you have studied this activity wherein we are finding area of a circle. How are we finding that? We are cutting a circle into small strips like a pizza strip. And then if we are arranging them in this manner, one on this side, two upside down, three, four, and so on, all the pieces when we arrange, it forms a rectangle. Okay, so the circumference is actually divided by 2 because this is the length, this is the length. Both together will give the circumference for you. So the length of the rectangle will be half of the circumference, which is half of 2 pi r. And the breadth, that is the radius of the circle, so r. Now area of the circle will be same as area of this rectangle, which is length into breadth. So half of 2 pi r, which is the length, into breadth is r, we get pi r square to be the area of the circle. So this is how we derive circumference and area of the circle. Now, based on this basic information, we'll just start with exercise 12.1, easy one. So first question, the radii of two circles are 19 centimeter and 9 centimeter respectively. Find the radius of the circle which has circumference equal to the sum of the circumferences of the two circles. So first we'll take the radius of the first circle R1 as 19 and radius of the second circle R2 as 9. So for the new circle which is formed by sum of these two circumference, let the radius be capital R. So circumference of the circle, we know the formula is 2 pi r. Now, circumference of the new circle is circumference of first circle plus circumference of the second circle. So, 2 pi capital R will be equal to 2 pi R1 plus 2 pi R2. We'll take 2 pi common out, R1 plus R2, which is 19 plus 9, so 28. 2 pi will get cancelled. There is no need to substitute for pi over here. So, R is 28. Therefore, radius of the circle whose circumference is equal to the sum of the circumference of the given two circles is 28 centimeter. Same way, here the second question is the radii of two circles are given 8 centimeter and 6 centimeter. Find the radius of the circle having area equal to the sum of the areas of the two circles. Previous question was circumference, now it is area. So again, radius of the first circle R1 is 8 centimeter. Radius of the second circle R2 is 6 centimeter. Now we are going to take the radius of the new circle to be capital R. Given that area of the new circle is equal to area of first circle plus area of second circle. So we use the area formula. Pi capital R square is equal to pi R1 square plus pi R2 square. We'll substitute for R1 and R2, 8 and 6. When we substitute, 8 square is 64, 6 square is 36, so we get 100. Now pi will get cancelled on both the sides, so R will be plus or minus 10. It is essential you write plus or minus. Then we have to write the statement. However, radius cannot be negative, so we'll take only the positive value. Though it is understood, you have to write that sentence. So therefore, radius of the circle having area equal to the sum of the areas of the two circles is 10 centimeter. Okay. Now let us move on to the fourth one. The wheels of a car are of diameter 80 centimeter each. Diameter is given here. Note that. How many complete revolution does each wheel make in 10 minutes when the car is traveling at a speed of 66 kilometer per hour? Diameter of the car, wheel of the car is 80 centimeter. So radius will be half of it, 40 centimeter. Circumference of the wheel is 2 pi r. So we are not substituting pi for now. We'll just write it as 80 pi. Okay. How many complete revolution? Okay. And speed is given to us. So how do we find the revolution? Why are we taking circumference? See, in this one, suppose this is the wheel of the car and this is the point at which it is starting. Then for it to make complete revolution, one full when it makes, that will be same as the distance traveled, and that is the circumference of the circle. In this way, see, it is making one whole round, and that is equal to the distance traveled, and that is same as the circumference of the circle. So speed of the car 66 is given. That will be, we are converting kilometer per hour to centimeter per minute. Then we get 1,10,000. Okay. So distance traveled by the car is this in 10 minutes will be one more. We are going to multiply by 10. So how much is it? 11 lakh centimeter. So whatever speed they have given, that is the distance traveled. Okay. Now we have to find the number of revolutions. Let us take that to be n. So n times distance traveled in one revolution. One revolution means one whole round, isn't it? Will be same as distance traveled in 10 minutes. So n times, we already found circumference to be 80 pi. This is 11 lakh. When we substitute, we get n to be 4375 when we have pi as 22 by 7. So the wheel of the car will make 4,375 revolutions in total. Okay. Now moving on to the next topic, sector of a circle. You all are aware of all these terms. We have already seen in the circles chapter also. So the portion of the circular region enclosed by the radii and the arc. Here radii is OA and OB, the arc APB. So this shaded part is called as the minor sector because it is small, and the other part is called as the major sector. And every time when we denote the sector, we denote the center, the arc, and one midpoint. One point in between need not be midpoint, can be anywhere, so that we are sure whether it is minor sector or major sector. So over here, OAPB is the minor sector, OAQB will be the major sector. Okay. And segment of a circle. Now, the portion between the chord and the arc is called as the segment. Here again, we are having minor segment and major segment. How are we denoting that? The chord AB and a point in between them. So APB is a minor segment and AQB will be the major segment. Now, area of the sector. You know what is sector, what is segment. Now we are moving on to the new thing, area. So for that, let OAPB be the sector with center O and radius R. And the angle made by the arc is theta. Okay. Now, area of the circle, we know it is pi r square. Okay, so area of the circle means this angle, we are taking it for the whole circle, isn't it? So what is the whole angle for a point? 360 degree. So for 360 degree, area is pi r square. So for 1 degree, area will be pi r square by 360. So for theta, it's going to be pi r square by 360 into theta, or usually we write it as theta by 360 into pi r square. So the angle multiplied by area of the square, angle divided by the total, the ratio into pi r square will be the area of a sector. Now, length of the arc, same concept. But the thing is, for the length, it is going to be circumference. Okay, so length of the arc will be theta by 360 into 2 pi r. Whatever angle, that one's length from the total, which is circumference of the circle. So that is how we get length of an arc. Now, area of the segment. Here, segment is APB, the minor segment formula only we are going to see now. For that, we have to find area of the sector OAPB, subtract area of the triangle OAB. So there is no definite formula for this. The same concept only is the formula. So theta by 360 into pi r square is the area of the sector minus area of triangle OAB. That's all. So with this, let us move on to exercise 12.2, question number 1. Find the area of a sector of a circle with radius 6 centimeter if angle of the sector is 60 degree. So angle is given to be 60 degree, radius is given 6 centimeter. We have to find area. What is the formula for finding the area? So area of the sector, first we'll draw the circle. We mark OACB to be the sector with 60 degree and 6 centimeter. Area of the sector is theta by 360 into pi r square, substituting 60 by 360 into 22 by 7 into 6 square. Unless they specify, we can take pi value to be 22 by 7. So it is 132 by 7 centimeter square. So area is 132 by 7 centimeter square. You needn't convert this in decimal points. It's okay to leave it in fractions. Now, moving on to the third question. Length of the minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 5 minutes. Now, we know that for 1 hour, that is for 60 minutes, the minute hand makes a complete rotation, isn't it? That is, it goes 360 degree in 1 hour or 60 minutes. So for 5 minutes, it will be 360 by 60 into 5, which is 30 degree. So in 5 minutes, how much angle it is moving? It is taking 30 degree. Okay. So we have the degree, we have radius also. We just have to find the area. So theta by 360 into pi r square. Substituting theta is 30 degree. Our radius is 14 centimeter given to us. So solving, we get 154 divided by 3 centimeter square. Now the next one, a chord of a circle of radius 10 centimeter subtends a right angle at the center. Find the area of the minor segment and the major sector. Okay, so now let AB be the chord of the circle and it is subtending 90 degree at the center. Now area of the minor sector we need, because we have to find minor segment. For that we need the minor sector first. So minor sector OACB will be 90 degree. Now for finding major sector, we have to take OADB. So what is the angle over there? Total is 360. Subtract 90, we will get 270. So 270 by 360 into pi r square. So 235.5 centimeter square will be area of the major sector. So we have found the second part. Now we need minor sector for finding the segment. So area of the minor sector is 90 by 360 into pi r square, which is 78.5 centimeter square. Now we find area of the triangle OAB, half base into height. Base is OA, height is OB. Both are radius. Radius is 10 centimeter. So 50 centimeter square is the area of the triangle. Now area of the segment ACBA. This is the segment for us. Minor segment is area of the minor sector OACB minus area of triangle OAB. Now, if we are writing minor segment also is ACB, then there is no difference between arc ACB and segment ACB. That's why we are writing a complete figure, which is ACB A. We are repeating A for segment. Okay, so we found the value 78.5 minus 50, which is 28.5 centimeter square. Okay, so we have seen area of a sector, length, and segment, area of segment. So we'll continue in the next video. Thank you.